So let me start with what is going to be my agenda. I'm going to start with, as I said, what is understanding reality. I'm going to talk about that. And I'm going to talk about how you can design and what will be the future. And predicting about future is always difficult. So we'll talk about that. And I'm going to bring in a context of an emotion, how emotion helps you understand user behavior and how you could use it, what kind of systems we are building. We'll talk about that a little bit. A little bit about IoT and how they help you do these things. We'll talk about that. Then I'm going to come back to the philosophical part. What is vision? How you can do it? What would enable you to build new products? So it's a philosophical kind of a talk, but hopefully it will give you new ideas and ways of thinking about solutions. So that's what I'm going to do. So let me start with, so this is my topic, future direction of AR, VR using emotion. So let me start with the future part. What is the future? So there is this stone carving in a temple in Tanjore. It's called the Big Temple in Tanjore. The stone carving has got all the predictions for Kali Yuga for the next 5,000 years. So it's got all these very interesting predictions. So one of the predictions there is, they say in Kali Yuga, light will burn upside down. And it is like, I'm sure when the prediction was given, nobody ever believed it. They said, you put a candle, even if you put it upside down, the fire always goes up. You would never expect something to be burning from upside down. It's not possible, right? But today we see lights all, upside down, or any angle is possible, because that's what has happened, right? So what I'm trying to say is that if you remove the actual current product features or the way of things working, and if you try to look at what you're trying to achieve, it's always better to have light at the top because you can actually cover more area. It makes sense. It makes sense to have light at a higher plane. So if you're trying to do that, and then if you start building from those, then you start seeing different levels of solution, right? That's what we're going to do. So I'm going to talk to you about how to do that. We're going to remove layers of things in virtual reality and come up with new kind of solutions. So as he was mentioning earlier, the thing about virtual reality is that there is an eye that is only a pass-through filter. It's not doing anything. Okay, so if you happen to see a bottle, then that's your reality. It's not there. Okay, so the eye is basically telling you what you're seeing, and but what is actually happening is in the brain. So the target for virtual reality is the brain, not the eye. Eye is just a pass-through filter. So we will even come to that. You don't actually need the eye as well, because that's also not required. We'll come to that in a minute, right? So coming back, let me start with an old story. Old story, this is a story written by Adi Shankara. So he wrote this Dakshinamurti Ashtotra, slogan he wrote in Kasi. So many of you would be familiar with the one Guru Brahma, Guru Vishnu, Guru Deva, that's part of this. So, but I will take another stanza out of that. That stanza says, Mauna Vyakya Parakadita Parabrahma Tattvam Yuvanam Vashishtan Devasatrukshaganai Avirtam Brahmanishtahi Acharyendram Karagalitta Chinmutramanandamurtim Swatmarama Mudidavadanam Dakshinamurti Mide. There's a reason I'm putting this, okay? So he is Dakshinamurti, and there are 4 Sanakadikals who are sitting with him, and he is giving them a message. And the message is basically Maunam Vyakya. So he is giving the message by Maunam. He is not talking anything. And he is giving this as a message. Right now you will say Facebook is this, but this used to be the popular thing earlier. Okay? So he is giving this Chinmutra Manandamurti. He is saying, if you got this, Parabrahma Tattvanam. And they figured it out. And they said, oh, we got it. And they all walked out. And the whole creation didn't start. And so Brahma had to go back and start the creation all over again. Okay, Sanakadika is the first 4 that created. Okay, so why I'm saying that is, if I show you this, you're like, okay, this doesn't look like the Facebook like. You don't get it, right? Neither did I. But what I'm saying is the reality is totally dependent upon your conditioning. And that conditioning that Sanakadikal had was completely different. And what we have is different. We see the same thing, we don't get it. So that's the point I'm trying to make. It depends on your own emotional state. It's got nothing to do with the message. So we first try to remove that part, that it's got nothing to do with what you're showing. It's got to do with how you condition the mind. So if you target the mind, like what you can do, how do you condition the mind, you completely get to a different kind of a solution. That's what we're going to talk about, right? Now, having come that, now we're finished with that, let's get into the emotion part as well. Now, emotion is a very old thing. People have studied it. And this is a very 1964 paper which talked about FACS, we talked about the facial action coding system, where they codified the different facial actions of people to try to find out emotion, which is a very popular thing today. There are lots of products that actually are able to capture the emotion of the people based on the facial expression. And why this is popular, and I want to tell you from a design point of view, there are few things that technologies that will become popular. Emotion is one of it. Why it is that if you have a user, especially retail or anybody for that matter, there are some types of data you have to get consent. If you have to use somebody's phone number, you have to get a consent. You cannot just take the phone number and use it. But if somebody is going to come into your shop, then you can put a surveillance camera and record their actions, and you don't need to get a consent. You don't need to get a signature saying that I'm going to use your recording to find out whether you stole anything from me or not, because that is allowed. There are legal things that allow. Okay? So why I'm saying that is, today if you have, let's say, a surveillance camera and you're able to extract user emotion from that, based on if people are walking into a shop and they're seeing some product, how are they happy? Are they happy? Are they sad? Do they like the pricing? Are they surprised? What kind of emotion can you judge and what can you do with it? You don't need to get a consent today. So these technologies we are working on, and it's possible today to do it. So let me, and coming back from a technology point of view, although the facial action and even emotion using voice is a very prevalent technology, it's fairly accurate. There are a whole bunch of solutions for it. We're also building it. But the EEG, which basically captures your brain wave, is the most accurate way of measuring human emotion. But today the EEG caps are like skull caps, and they're very, what do you call it, as clunky, just like your VR device you was talking about is very clunky. But you don't need that. You don't need that, and we'll talk about that in a minute. Once I come to IoT, I'll talk about that. You don't need that. Okay, you could do that even without it. Now coming back, what kind of emotion can you capture? I'll just show you some video examples of that. So you have these various emotions like happy, sad, angry, everything. So depending upon where you're coding, it's just fairly straightforward deep learning algorithms. Anybody who has done convolutional neural networks or things like that, it's very straightforward. You can do this. These kind of technologies exist. You can see enough videos, enough demos. There are things that are out there. So I'm not going to talk about that. But this is the kind of work that we are doing for some of our customers. So, building emotion-based solutions and things like that. But I will try and come back and map this to the virtual reality. Okay? So we'll move on from that user. Okay, so now let's just quickly understand IoT, because that's part of my solution. So I need to explain IoT in my own language. So IoT is nothing. There is a thing. The thing could be anything. It could be a tube light. It could be a laptop, or it could be a button, whatever. And then the thing, you're going to attach some sensor. And the sensor has to have a unique ID. And the unique ID is very important. Why it is very important is, if I have a sensor here, if I have a sensor there, I need to know which sensor is telling me the temperature. The temperature here could be very different from the temperature on that side. So I need to know where the temperature is coming from, where is the data coming from. So that unique ID is very important. And that's where we started with IPv6, where the number of IDs are like so many billion, we need that, right? So that unique ID is very important. And then there is going to be a sensor. And the sensor could measure anything. It could be temperature, pressure, vibration, whole bunch of stuff that we'll talk about in a minute. The main difference between a vanilla thermometer and an IoT device is it has a connectivity where it is able to transmit some data, saying that, okay, I measured this temperature, the temperature here is 25 or 26, and it's able to transmit that, and that is very important. Okay, the transmission is very important. Otherwise, a thermometer would do. Thermometer is also measuring, but it doesn't have unique ID. This is an optional piece where you could, for example, automatically regulate the AC based on temperature in the room. There is no analytics, there is no nothing. But you could take it and find out, okay, I'm thinking that this place is cold, he's thinking this place is warm. So there is a, it's based on my conditioning. The ground truth, which is the actual temperature, is the same. 25 could be hot for me, 25 could be cold for him, but the ground truth is different. The IoT gives you the ground truth. And then based on who it is, what they want, you can actually do the configuring, analytics, personalization, everything that you want to do based on the analytics in the backend. That's what the backend is going to do. But I want to keep focus on this particular ID part, because based on the ID is where we're doing everything, okay? And then there's like a whole bunch of frameworks that, I'm not going to go into these, that actually separate this IoT into layers. They tell you, there are trade-offs between the protocols in terms of what you can get, how much distance can it transmit. Okay, the lower the transmission requirement, the lower the battery requirement, otherwise it will die. IoT is not high-powered devices, right? So what do you want to do? How do you do maintenance? Okay, but this is a slide that from industrial context, but still it's useful for a retail context, but I want to tell you, there's a whole bunch of sensors that are available, right? And the sensors, when you combine data, they're going to give you a whole bunch of stuff. It's going to be either biometric or pressure or temperature or whatever that you want to measure. So a whole bunch of things that you could do. Okay, basically the 5 sensors, not the 6th one, right? So that's what we're going to do. Now that we know IoT, let's come back to the concept of core concept, like what is in vision? What is in vision, and what is the difference between vision and eyesight? The biggest hurdle here to overcome is that you think you need eyes, okay? And every time, we try to design an AR VR system, we tend to think about, oh, you need eyesight, you need eyes, you need glasses, and I want you to cut that problem out. That's not required, okay? And I'll tell you why. Because if you understand what we are trying to do, you'll understand where I'm coming from. First thing is, the goal is to identify and to understand. If I show you something, if I show you a mic, if I show you a board, the goal is to make the user understand, oh, this is a board and this is a mic. And the goal is to make that happen. And for that, there's really no need for an eye. Let us look at why it is the case. Let's take a bat, for example, right? Bats lives in caves, they're able to feed. They're actually able to send back sonar waves. All of you are familiar with that, right? And they're able to identify the prey. They're able to do the identification, they eat, they live, they survive. It's one of the oldest mammals around. Okay, so you really don't need eyes. That's sort of an example that I can give you. Okay, so that's the first thing. Second thing is, I wanted to think about an X-ray, which is so obvious to you right now. Okay, but you can't see that with your eyes, right? If I show you a leg and put it on an X-ray machine, it's showing you, okay, here's your bone, here's your broken bone or whatever. Going further, if you think about the MRI, it doesn't even use X-rays, but a CT scan is even further. It is actually called computed tomography, meaning there is no imaging, it is computation. Based on basically echoes of waves that they send to your body, they compute and tell you how the body is, what is actually happening. It's computed. Okay, so what I'm trying to say is that to present a reality to someone and to think that you need eyes for the person to be having an eye is a myth. It's not required, absolutely not required. And if you so much focus on having a camera, oh, I have to have a camera that I can take a feedback from the front of me, what is in front of me, it's absolutely not required. Okay, it's absolutely not required because you don't need a camera, and the camera is a very limited,